Okay, trig functions, under its simplest definition, a trigonometric, literally triangle measuring, function is one of the many functions that relates one non-right angle of a triangle to the ratio of the lengths of any two sides of the triangle, or vice versa. The relationship between an angle and the side ratios in a right triangle is one of the most important ideas in trigonometry. Trig ratios work for all right triangles. Not every triangle, just right triangles. So you have to know that it is a right triangle, has that 90-degree angle in it. If we need to find the measure of a side or an angle, side or an angle, oh yes, or an angle in a right triangle, we can find the missing value by using the ratio of the sides of the triangle and the corresponding trig function to find the missing value. In order to calculate the trigonometric function, you need to identify the angle you are going to use, the opposite side, the adjacent side, and the hypotenuse. So that's what we're going to start with. We're going to start by just identifying the opposite, the adjacent, and the hypotenuse of a right triangle. So with angle A, so you always want to know which angle you're working with, because opposite and adjacent will be different based on which angle you're looking at. So in this case, we're looking at angle A. So circle it or highlight it, however you want to identify it. Okay, the opposite side is the side that doesn't make up the angle. So if you see this angle here, I'm going to label all the sides in different colors. Which side doesn't make up the angle?
AC.
Okay, AC is part of that angle because it has the A in it, right?
BC.
Okay, BC isn't part of that angle because it doesn't have the A in it. Does that make sense? So this is our opposite side. Okay, and I want it inside. That's the opposite side. Then the adjacent side is the non-hypotenuse that makes up part of the angle. Okay, so it's either AB or AC. So is AB the hypotenuse or the adjacent side? Adjacent. Okay, good. Anyone unclear as to why it's the adjacent? We're good? Okay, so this is my adjacent side. Okay, and the hypotenuse is always opposite the right angle, or the longest side. So this is the hypotenuse. Any questions over that? Okay, let's do the next one. So over B, we want to look at angle B, which is right here. I'm going to color them. Okay, Genesis, which one is the opposite side? CA, okay, because it doesn't have the B in it, right? It doesn't make up that angle. So this is the opposite side. Marco, what would be the adjacent side then?
CB.
CB, very good. It's the non-hypotenuse that makes up the angle. So this is adjacent. And then the green is the hypotenuse. Any questions over that? We're all good? Okay, do the next one on your own. Okay, so this was our opposite side of angle N. This is our adjacent side. And this is our hypotenuse. Any questions over that? Pretty easy, right? Okay. Just so you know, the right angle will never be the angle used to find the trigonometric ratio. Okay, you'll never be asked to find the trig function of, in this triangle, angle C, in this triangle, angle M, in this triangle, angle B. You'll never be asked to find those trig functions based on the right angle. Yes? Okay, so our trig functions. Okay, our three basic trig functions that we'll learn this year are sine, cosine, and tangent. These are things that you will see from now on in Math 3. You'll see this in pre-cal and calc. You'll see the trig ratios for sine, cosine, and tangent, and then you'll also learn 3 others, okay, and their inverses. But today we're going to focus on sine, cosine, and tangent. Sine of theta, that's this angle right here. That's theta. It's a Greek letter, and they usually use it for angles. Is the opposite. Over the hypotenuse. Sine is the opposite of hypotenuse. And remember it by doing sine, opposite, hypotenuse, over hypotenuse. That's SO of SOHCAHTOA. Okay, SOHCAHTOA is a pneumatic device that we're going to use to remember sine, cosine, and tangent. SOHCAHTOA. Okay, cosine of theta is the adjacent side over the hypotenuse. And remember that by cosine equals adjacent over hypotenuse, which is the K of our mnemonic device to help us remember our trig ratios. Okay, tangent then is opposite over adjacent. tangent of theta is opposite over adjacent. Okay, and it's the TOA. So tangent equals opposite over adjacent. It's the TOA of the mnemonic device. So if you remember SOHCAHTOA, then you can write it down, and every time you see it, you'll see sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Okay? That's how to remember this, because you need to memorize our trig ratios. You need to memorize the sides of our sine, cosine, and tangent. Any questions over that? We're all good? Okay, find the sine, cosine, and tangent for the given angle. So the first thing we need to do is identify the opposite, adjacent, and hypotenuse of the given angle. So in this case, we're going to be given angle B, so I'm going to highlight it. Okay, Riley, what's the opposite side?
27 AC.
AC, very good. Opposite. Let's label it with O. Chris, what's the adjacent side? Ben. BC. And we're just going to label it A. And then Jacob, what's the hypotenuse?
AC.
AB. And we're just going to label it H. Any questions over that? Okay, so for the sine of B, that's how you write it, equals, it is the SO of SOHCAHTOA. So it is my opposite over hypotenuse. Okay, so I take the opposite side over the hypotenuse, which we have, the opposite side is 7 over the hypotenuse of square root 65. And that's the sine of B. Yep.
Do you want us to solve it or just leave it like that?
If you can simplify, you simplify. In this case, I cannot simplify this, so we're done. Now we're going to find the cosine of B. Jeremy? What do you need to know? Oh, there you are. Okay. What is the ratio for cosine? What over what?
Adjacent over hypotenuse.
Very good. Adjacent over hypotenuse. Okay, so I'm going to look at my figure. I'm going to have adjacent is 4 over the hypotenuse of the square root of 65. So the cosine of B equals 4 over the square root of 65. Any questions over that? Okay, again, we would reduce if we could, but 4 and 6 and the square root of 65 can't be reduced at all, so we just leave it. Okay, everyone find the tangent now for me. Okay, so then tangent of B should be the opposite over adjacent, which will equal 7 over 4. Make sure you have 7 on top and 4 on the bottom. It has to be opposite over adjacent. If you gave me adjacent over opposite, that is not tangent, that's cotangent, which you will learn next year. Questions? We got this? It's pretty easy so far, right? Okay. We're gonna continue it. Now we're just gonna find sine of B. So your first step is to label. Label opposite, adjacent, and hypotenuse. Okay, then what's the opposite side? Oh, let's label B. What's the opposite of angle B? It has to be two letters if it's a side. CD. This is my opposite side. Miko, what is the adjacent side? DB is adjacent, good. And Gianna will be the hypotenuse then? BC, very good. Okay, then we need the ratio of sine. Okay, Bree, what's the ratio of sine? Opposite over hypotenuse. Very good. I should probably write that better. Okay, so we're going to do our opposite side and our hypotenuse. So we're going to take the sine of B equals 2 over 2 square root 5. This we can reduce, so we're going to reduce. So 2 and 2 are both outside of the radical, so you can reduce those. 2 divided by 2 is 1, and 2 divided by 2 is 1. So you get the sine of B equals 1 over the square root of 5. And you're just going to leave it like that. Any questions over that? We're doing okay? Next one. Okay, cosine of D. Label all the sides and come up with cosine for me. Okay, so let's try this again. So with angle D, this is my opposite, this is the adjacent, this is the hypotenuse. Cosine equals adjacent over hypotenuse. So the cosine of angle D should equal my adjacent side over my hypotenuse side. So 8 over 10. I'm going to reduce that by 2, divide them both by 2. And I'm going to get the cosine of D equals 4 over 5. Any questions over that? Okay. Next one. Now it's asking you to find the tangent of N. So we need to label. Again, you want to look at the angle that you're given, angle N. We want to find the opposite side. Okay, so if I look at angle N, the one it doesn't touch is LM. This is my opposite side. Then this is the hypotenuse. So this has to be the adjacent side. The only issue is I don't have the length of that side.
That we use on diagram.
Yes. So write this down. 2, find the missing side of a right triangle we need to use the Pythagorean theorem. Okay, to find the missing side of a right triangle, we need to use the Pythagorean theorem, which is a squared plus b squared equals the hypotenuse squared. Okay, we label the hypotenuse as c, but I want to make sure you know it's the hypotenuse squared. Any questions over that? Okay, move this. Let's see, moving all this whole thing. Very, very interesting. Okay, so we want to do 6 squared plus the a squared, adjacent side squared, equals my hypotenuse squared, which is 8 squared. Any questions over that? You can use any variable you want to for that missing side. I just chose a because it's the adjacent side. Then I'm going to solve. So 6 squared is 36 plus a squared equals 64. I'm going to subtract 36 from both sides. I'm going to get a squared equals 20? No. 28?
Yeah.
28. Okay, then we need to square root both sides. Okay, we have to simplify 28. Find our pairs. So it's 4 times 7, then 2 times 2. Okay, let's review. For a radical, the pairs get outside the radical. So a is going to equal the 2's on the outside, square root, and what stays inside is the thing that doesn't have a pair. So 7 is on the inside. Any questions over that? So that's a. So 2 square root 7 is my a value. Any questions over that? Now that we've found the missing side, now we can find the tangent of n. Trinity, what is my ratio for tangent?
Opposite over adjacent.
It's opposite over adjacent. So this is my adjacent side and this is my opposite side. So tangent of n equals 6 over 2 square root 7. And then we need to reduce. So 2 and 6 can both be divided by 2. So my tangent of angle n equals 3 over the square root of 7. Any questions over that? Okay. Okay, for this, other types of problems that are not going to be trig related are going to ask you to find all the missing sides and all the missing angles of a right triangle. So the two things we need to remember, one we already covered is the Pythagorean theorem. Which was our a squared plus b squared equals the hypotenuse squared. And the other is a theorem about angles in a triangle. And someone remind me, how many degrees? Yep. There's 180 degrees in a right triangle. So we have the triangle sum theorem. The sum of the interior angles in a triangle equals 180 degrees. Any questions over that? So now we should be able to find all of the missing angles and all of the missing sides. So let's start with the Pythagorean theorem. So the only thing I really need to care about right now is that this is the hypotenuse. Okay, I'm going to put this, label this as x, just so I know what side I'm looking for. So I'm going to get four squared plus x squared equals my hypotenuse squared. So I'm going to get 16 plus x squared equals 36. I'm going to subtract the 16. I'm going to get x squared equals 20. Then I'm going to square root both sides. I'm going to get x equals, let's factor 20. Okay, please write that as a radical. And what'd you get as the answer?
2 square root 5.
Very good, 2 square root 5. The 2's get outside the radical, and the 5 stays inside. Any questions over that? Okay, so we have this missing side. 2 square root 5. Now we have to find the measure of angle D. I'm looking for the measure of angle D now. And this triangle sum theorem says that the sum of the interior angles is 180 degrees. So I know that the measure of angle D plus 34, then plus the right angle. And how many degrees are in a right angle, class? 90. Should equal 180. Yep.
56.
Okay, let's do all the math. I'm glad that you did it already. So the measure of angle D plus 124 equals 180. I'm going to subtract 124 from both sides. And I'm going to get the measure of angle D equals 56 degrees, which is what Kyle said. Now I have all the sides and all the angles. I'm just going to write it in on my triangle so we have it all together. Any questions over that? So your first 6 problems, I think, on your homework are like this, where you're just finding the missing sides and the missing angles. Any questions? Okay, now, I want you to work on this, but before you do, I want you to write these angles in. I should have written them in, but I forgot to. $30 and 60. 30 degrees and 60 degrees. Okay? I want you to find all the trig ratios and then answer those questions for me. Okay, so what did we notice? We raise our hands. Yes.
The ratios are the same.
Okay, the trig ratios are the same for each triangle. So for the sine of A here, we got the square root of 3. It's interesting. Okay. Square root of 3 over 2. The cosine was 1/2 when we reduced. And then the tangent was just the square root of 3 when we reduced. Same with the sine of D, square root of 3 over 2, 1/2, and then tangent was square root of 3. Any questions over that? We're good? So all the trig ratios were the same in the 2 triangles. Okay, anyone else notice something? Yep.
The angles are the same.
The angles are the same. Angle A equals 30 degrees, not 30, 60 degrees. And angle D equals 60 degrees. Sorry, the measure of angle. Okay, so you're looking for the ratios for the same angle, Kyle. Anything else we noticed? Yep.
Triangle DEF is twice as big as ABC.
Very good. Triangle ABC is half of triangle, or you could do it the other way that he said. Triangle DEF. You can say that triangle DEF is twice as big as triangle ABC. What do we call that? A dilation.
Dilation of two.
And when we have the angles that are congruent and the sides that are proportional, what do we call that? Go back to the very top of your page that we wrote down.
Similar.
Similar. So we would say that triangle ABC is similar to triangle DEF. Okay. Okay, and then why did you think the relationships you have that you noticed occurred? Why do you think that? Why did you think the trig ratios were the same?
The triangles are similar.
Because the triangles are similar? Anyone other reasons we can think of? Yeah?
Because it's just double.
Because it's just double, and then you can divide everything else by 2. Okay. Because we should probably say that better. Triangle ABC the triangle DEF is a dilation of triangle ABC, or vice versa. However, we didn't tell us which one came first. We don't know. How about the angles? Well, we talked about the angles. Because the angles are the same. Because angle D and angle A are the same. They both equal 60 degrees. Okay, could we get the same results if we were given 2 other triangles? And if so, what do we need?
Equal angles.
Okay. Only if the angles were congruent. Any other things you could think of? What's another way of saying that same exact thing? Yeah,
If they're similar.
very good. If the 2 triangles are similar. Because if they're similar, then the angles are going to be congruent too. And you used the corresponding angles. Okay, so the key from this is that all 30, 60, 90 right triangles. So if you have a triangle that has congruent angles, then all of the trig functions are going to match. you'll have all the same ratios. Any 30, 60, 90 right triangle is going to have these ratios for one of the angles. The square root of 3 over 2, cosine would be 1/2, tangent would be the square root of 3. For one of the angles. Any questions over that? Okay, your homework is in your big packet.